Hello everyone. So today we are with one new contest, which is Codeforces Round 775, Div 2. Okay, and yeah, it's an open contest, and all the very best to you all. Today we have, when it's like it is opening in couple of seconds. So all the very best, and we will do our best. Fine. So let's open. Yeah. Okay. So today the server is little bit low and slow. Okay, it's happening like. I think my net is fine only, but the server is slow today. Yeah, it had opened. Let's open the things. Fine. Okay, okay. That's fine. What the question is saying, there's several ways first line. Okay. First name, second minor. The test case contain sequence. Okay, where EI equal to 1 means the ith location is the location with land and I guess location very that. Yeah, a of 1 equal to 1 and land. For each test case, print a single integer answer to the problem. We're playing a very popular computer game. The next level consists of n consecutive location, number from 1 to n, each of them containing, okay, it is known that first and last location contain land, and for completing the level you have to move from first location to the last. Also, if you become inside a location with water, you will die. So can only move between location with land. You can jump between adjacent location for free, as well as no more than once jump from any location with land I to any location I plus x, spending x coins. Fine. Your task to spend the minimum possible number of coins to move from first location to last. Note that this is always possible since both locations are land. Okay, so 0. We can move to adjacent. You can jump between adjacent location for free, as well as no more than once jump from any location with land I to location land to location with land I plus x, spending x coins. The first case, it is enough to make one free jump from first location to second, which is also the last one, so answer is 0. Here in the second case, the only way to move from first location to the last one to jump between them, this will cost 2 jumps. It did fine. 1, 2, and I to any location I plus x, 2 to 4. Here 2, then adjacent, it's fine. How we can do this? It's just like so I'm going to calculate the ones between them. That's the only thing which we can do. So yeah, let's start the code. Let's start the code. Okay. Uh, Fine. So P is of I, and after that, what we need to do? We'll start from one to go till there and calculate the sum equal to 0, and let's say a of I is equal to 1. So we will first check that if I equal to a of I minus 1. Uh, if yes, so no problem. We will calculate the difference between them. Previous one is as equal to their index is 0. So else sum plus equal to this index minus fine when this had visited. And yeah, now we initialize this as I. So this would be the case, and yeah, it would give us answer. We have and so let's check it out. This yeah, I did something mistake here. 042. Yeah, it's fine. I think it should work. Okay, they had attempted, and I need to do. Okay, let's take for some another test case also. Let's take 5. If I am putting 1, 1, 1, 1, 1, 3, 4, 5. So let's just uh, wait a second. Here, I need to. Yeah, it's working. If I put here 0, so let's see. Answer it is giving 4, which is wrong. Starting from 1, okay, C out pref 0, 1. So A of I is 1. Yeah, it is 1. And it is checking that this and this. Yeah, yeah, I got it. Don't need to continue anything. Uh, we can say that sum plus equal to 0. Let's say this. Like so 0, 0, 0. From here, it need to do 2 jumps. Fine. 2. Like here also, they need to do 2. Fine. At least 2 it required. And if I put like 3, so yeah, from here it would require 3 jumps, And if I do one thing, 3, it's fine. Like this, I'm checking this, is giving us 4. So I think it is correct. Uh, okay. I think the approach is right only. So let's submit this question. Oh, wrong test on pretest 2. What could be wrong here? I think I hadn't read the question properly. Minimum possible number of coin. There are first line, okay. The first line of each test case contain one integer n, the number of locations. The second line of test case contain this. Fine. Here is right. You are playing very well. The next level consists of n consecutive location number from 1 to n, each of them containing other land. It is known that the first and last location contain land, and for completing the level you have to move from first location to the last. Also, if you become inside a location with water, you will die. So yeah, only move between land. You can jump between adjacent location for free, as well as no more than once jump, as well as no more than once jump from any location with land I to any location with land I plus x, spending x coins. Uh, as well as no more than once jump, no more than once jump any location with land I, okay, land 0 to any location with land I plus x, and I plus x, spending x coins. X should be greater than equal to 0. Land I plus x, a location with land I. Okay, this is land 2, 1 and 2. 1 plus 2, 3. Spend, here it would spend 2. Then here it is how much? 2. It is how much? 2. So it is like 5. So 2 plus 2. Sorry, this land is 3. Second land. This is second land, and with land I plus expending x coins. This is how much? This is our first land, second land, third land. Okay, 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 fine, fine, fine. So, while going here from first to second land, it had to spend 1, and first to second land, it had to spend 1 coin, and as well as no more than once jump from any location with land I, no more than once jump from any location with land I to any location with land I plus x spending x coins. No more than once jump. As well as no more than once jump. from any location with land I to any location with land I plus x. Location with land I. As well as no more than once jump from any location with land I. Uh, No more than, as well as no more than once jump from, as well as no more than once jump from any location with land I to any location with land I plus expanding x points. So it asks to spend minimum possible number of points to move from first location to last. First location to the last one is a jump between them. They will cost 4 points. Third case, you can jump from first location third for 2 points. And then jump from fourth location free. More than once jump. As well as no more than once jump from any location with land I to any location with land I plus x. First, second, third land it is. So while going from first to second line, spend how many jumps are there? Two jumps are there, so they need to spend two. And from second to third location, they need to spend. I'm not able to get the question. What the question was saying. Let's read the question again. Okay. You can jump between adjacent location for free. I can jump between adjacent location for free. Okay. So level consists of n consecutive locations, number from 1 to n, each of them containing either land or water. Okay. It is known that the first and last location contains land, and for completing the level, you have to move from first location to the last. Also, if you become inside the, you will die. So you can only move between the location with land. You can jump between adjacent location for free. I can jump freely with adjacent location, as well as no more than once, no as well as no more than one, no more than once jump from any location with land, any location with land I to any location with land I plus x. Here the land is 1 to 3, spending x coins. 2 coins it had moved to move from first location to the last one. Note that it always possible both of them, both the first and last location are the land location. So no more than once jump from any location with land I to any location, as well as no more than once jump from any location with land I to any location with land I plus x pending x points, as well as no more than once jump from any location with land I to any location with land I plus x pending x points. Here is the key point for free, as well as no more than one, as well as no more than once, as well as no more than once jump from, as well as no more than once, as well as no more than once jump, as well as more than once jump from, Okay, you can jump between adjacent portions as well as no more than once jump from any location with land I to any location with land I plus x spending x points, as well as no more than once okay, as well as no more than once jump from any location. You can jump from between adjacent as well as no more than once, as well as no more than. Where the test case is failing, like you can, as well as x could be 1 in some case. I think I'm not able to right now. So let's switch to the second question. What the question is saying, game of ball passing. Daniel is watching a football. Okay, there are several test cases in the input. The first line contains the number of test cases. This is followed by the test case description. The first line of each test case contains one integer, the number of players. Okay, the second line of the test case contains a sequence of integers. I is the number of passes delivered by the ith player. The first line of each test case number of players. The second line of the test case contains a sequence of integers, where ei is the number of passes delivered by the ith player. Okay, guarantee there's some. Okay, for each test case, print a single integer, the answer to the problem. Daniel is watching a football team playing a game during the training session. They want to improve their passing skills during the session. The game involved n players, okay, making multiple passes toward each other. Unfortunately, since the ball were moving too fast, the unfortunate 1 minute 3006. Okay, unfortunately, since the ball were moving too fast after the session, Daniel is unable to know how many balls were involved during the game. The only thing he knew is the number of passes delivered by each player during the session. Find minimum possible amount of ball that were involved in the game. So 2 pass from first player, 3 pass from second. Okay. In the first test case, with the only ball, the game is like 2 given to 1, 1 given to 3, 3 given to 4, 2 is given to 1. Gave pass to 1, 1 again gave pass to 3, and 4 gave pass to 1, 2, 3, 4. What the hell it is? Sybil play the game with only one ball. I think not able to do this one. Let's see this question. C1. Question is saying Eager has okay, the first line input number of rows and columns. Each next line, ith line, m integers. Fine. The ith line contain m integers. The color of the cells in the ith row. Next n line describe a row of the table. The ith line contain m integers. The color of cells in the ith row. Print one integer the sum of Manhattan distance between each pair of the cell of the same color. Eager has a table of size n cross m. 1 to n. Okay. Each cell has a color that can be represented as an integral from 1 to 10 raised to power 9. The size. Okay. Each cell has a color that can be represented as an integer from. Okay. Let denote the cell that lies in the intersection of. We define the Manhattan distance between two cells as the length of the shortest path between them, where each consecutive cells in the path must be a common side. The path can go through cell of any color. I think this is also from graph only. Today contest is little bit different from previous one. The first line of the test is contained to integer the size. Before any two. Also in the array. You are guaranteed that the okay. Up to, it's like you have given an array. Let's call an array integral. If for any two, not necessarily different, any two different number x and y from the array, the number this is also inside the array. 1 to 5. So if we take 5 divided by 2, which is giving us 2. So 2 is there. The first test case. Uh, Wait a second. Okay. Yeah. First test case. It is easy to see that the array integral 1 of 1 is always give us 1. 2 of 2. Okay. 5 of 5. Okay. 2 of 1 will give us 2. 5 of 1. Okay, like this. For every number they are checking the things. Fine. How could we do this? For any two number it should be valid. One should be there for one is the must condition. If one is not there, so directly write no. Otherwise, here I think DP would involve. So let's move to first question only. I think it is much more better to do focus on first question only. Got it. It is this condition. This discount is available for this particular like one. If both condition are true, then only otherwise this would be the case. So let's see one five one comma 1, 0, 1. Here no, but here charge 1, then 2, 3. Yeah, like this it would work. And I think it should give right answer. Again, wrong answer. Uh, okay, let's see. Let's again review the question. You can jump between adjacent location for free, as well as no more than once jump from any location. No more than once, as well as no more than once. As well as no more. Uh, let's wait from 1 minute. साथ ही किसी भी स्थान Okay, so let's see this. Flag equal to 1 only, then condition, otherwise flag equal to 0. Hmm, wait a second. I think only one time it could do. You can jump between adjacent location for free. Yeah, I can jump adjacent, okay. As well as no more than once jump from any location with land I to any location with land I plus x. As well as no more than once. Okay. साथ ही किसी भी स्थान is no more than once. As well as you you can jump between adjacent location for free, as well as no more than once jump from any location with land I. You can jump between adjacent location. I can jump between adjacent location for free, as well as no more than once. No more than one. एक से ज़्यादा बार नहीं. No more than once. What does this mean? Like he could not jump from one to another location more than once. Yeah, it is right now. He could not. You can jump between edges as well as no more than once jump from any location with land I too. Yeah, so you can depend on that. Okay. Okay. Uh, not able to get what the mistake I was doing. Okay. as well as no more than once jump from any location with land I to any location with land I plus x. Uh, Missing somewhere. Can move first location to the last. Also, if you become inside a location with water, if you become also if you become inside a location, sorry, not getting it. What could be the minimum cost? What the thing I am doing wrong here? Note that it's always possible since both the first and last location are land. So the first line contains a single location. This is followed by this. The second line of the test case contains a sequence of this. Yeah, equal to 1 means the ith location is land. We spend the minimum possible number of coins to move from first location. Minimum. He's asking a minimum. This one is as well as no more than once. You can jump between adjacent location for free. Yeah. As well as no more than once. As well as no more than once jump from any location with land I to any location with land I plus x spending x coins. You can jump between adjacent locations for free. Yeah, I can jump as well as. You can jump between adjacent. Not able to think like how we can do this, how I can do this. Sorry. Okay, for every single number it is checking. I could short the number. Yeah, it is already shorted over. So I will start from back. Three. If it is there, fine. There, fine, fine. Like this. I will start from back. So yeah, it's like division of any number and let's checking out. Okay, 3 7. But two is not. You guarantee that the number. Now given an array of elements. Okay. You are guaranteed that all number A does not exceed C. Limit is also given to us. Max number. The number in the array, just the array. Just one. Just one. How does he could play a role here? C. What's the role of C here? Let's wait. I'm coming. Here, C question what I think it should not cross the limit. It didn't cross the limit. So maximum value. You can jump between adjacent locations for free, as well as no more than once jump from any location with land I to any location with land I plus expending X coins. Your task is to spend the minimum possible number of coins to move from the first location to the last one. We can jump between adjacent locations for free. Literally, I'm not at all getting how this question had been done. This question could be easily done by brute force. It's not a graph question. It's like what we can say, like uh, by using means brute force, like we can find out the things while using map. But the thing is, like constant is so high. That's the problem always. Otherwise, it would be a easier one. Yeah, but constant is totally agreed. This is high. Let's see some optimized way of this. So if you see here, one having one, second player have five pass, third player have two passes. So what we can do? Number of players. How we can do this? This two will cut out. Every even number you should cut. Fine. And here left with like this odd ones. This is passing two times. It would pass. Three would pass two times. So if would play with two, let's do go like this. One and two. Minimum would be like four. With four and three left with two. Fine. So here also like three would go, so two left with two passes right now. One pass between both of them, like this, it would happen. Fine. So after that, this four passes he need to do with some another ball is also there. No? One more ball is there. Question is only weird sum. This today contest is like I can't say anything how it is going on. Okay, so wait a second. Let me try. Okay, let us denote. Let's try C also. Eager has a table. Each cell has a color that can be represented with an integers. Let us denote the cell that lies in the intersection of the Manhattan distance between two cells. Okay, as the length of the shortest path between them, where each consecutive cells in the path must have a common side. The path can go through cell of any color. For example, in table 3, the Manhattan distance between this is 3. One of the shortest path is 1 to 2, 2 to 3, 3 to 3. Eager decide to calculate the sum of Manhattan distance between each pair of the cell of the same color. Help him to find the Manhattan distance. Okay, so let's do here. At least we can understand. We should understand the things also. However, is the contest had gone? Let it be 3, 2, 1. So sum of the Manhattan distance between each pair of the cell of the same color. So if I calculate first, there are three pair of cell of same color: 1, 2, 2, 1, 1, comma 1, and 2, comma 3, and 1, comma 2, and 2, comma 2. Then 1, comma 3, and 2, comma 1. 1, 2, 3. Then here it would be 1, and here it would be 1, 2, 3. And if we talk about this table, if we consider this, 1, 1, 2, 2, 2, 1, 1, 2, 2, 2, 1, 1. So how many pair having same color? First of all, we will consider this two pairs. So its distance is 1. Then calculating this 2, 1, 2, 1 plus 2. Then this 2, 2. Okay, this much. Then it's like 1 plus 2 plus 3 plus 4 plus 5. 1, 1 plus 2 plus 3 plus 4. Then it is 1 plus 2 plus 3. Then 1 plus 2. Yeah, 1. It went for this. 2 comma 2, 1 comma 1, 2 comma 2, 2, 1, 2, 3, 4, 6 numbers are there. Okay, 30 minutes are left and uh, I stuck, badly stuck here. I almost tried every question like how I can do, but yeah, not able to solve anyone. But yeah, it's an interesting contest. Let's read again this question fully. You're playing a very popular computer game. The next level consists of n consecutive locations, numbered from 1 to n, each of them containing either land or water. It is known that the first and last location contain land, and for completing the level, you have to move from first location to the last. Okay, it is known that the okay if you become if you become inside a location with water, you will die. Yeah, so you can move only location which are land. Okay, you can jump from adjacent location from for free. Okay, you can jump between adjacent location for free. Fine, you can jump between adjacent location for free, as well as no more than once jump from any location which is I to any location I plus x spending x coins. Nothing means like a single jump would not means a single jump from I to ix it would cost around X, and it would be a one jump only, nothing more. You're tasked to spend the minimum possible number of coins to move from first location to the last one. Note that it is always possible since both the first and last location are the land location. Yeah. So first of all, let me review my code. That if I'm doing anything wrong here. Okay, I had taken an input, then array. Means I should open this also. Then that I had taken an array also. That after that I taken sum equal to 0, then previous equal to 0. Previous is a type of pointer which I'm indicating for the previous first element, like the first occurrence of that one. Okay, previous occurrence, sum 0, flag 1. Flag is not required. That I put mistake, no problem. And it is starting. As we know that the first location is always one only, so I started from this prev equal to 0. So I started from first index and I checked that the first index is like equal to 1, means it's an land. If I check for every index, yeah, if it's an land, then I'm going to check that this land is equal to I minus 1, means that previous one is also 1. So if both are 1, so means like ongoing there, no charge would cost us, the sum would be 0. Otherwise it would charge us, it would charge us I minus priv, and we are storing priv like land. Whenever the land is coming, we are storing here the index of this. Fine. So I calculated this, and that would be only thing. And yeah, after that I calculated the sum. Fine. But it is giving me wrong test case. Means still I'm lacking from some concept here, or we can say from some logic right now that I'm not getting. It is passing the case which I was thinking. Maybe the thing is that I am thinking the wrong. I am interpreting the question wrong. But as I read so many times, I'm clear like, okay, what is the significance like I plus X and spending X coins, where X could be equal to 0 or greater than 0. Means X could be 1. There could be a possible that only one coin we will use. There is a possibility. If this is the case, then we can go adjacent one from any location with land I to any location with land I plus X. Three land possibilities are there. So how we can do? The first case, it is enough to make one free jump from the first location to the second one, which is also the last one. So answer is 0. In second question, the only way to jump from first location to the last one to jump between them, in which will cost 4 points. Third question, you can jump from first location to the third for 2 points. Yeah, I had jumped by giving 2 points, and jump to the fourth location for free. I had jumped to third position with spending 2 points. Then jump from third to fourth free. So the answer is 2. It can be shown that this is the optimal way. That's the greedy approach. Always search the best optimal way. So, what's the thing I am doing wrong? Like, whatever the case I would take. Here also it would jump like this only. If I take like this, so here it would not cost anything. From here it would take some, how many jumps? One, two, three. Three jumps it would take. If I do like this, here it would cost me two jumps, two. Then from here it would again go two. From here it would again go two. From here it would again go. It would cost me two. Then till here no problem. Then from here it would again go. It would cost me two. From here no problem. So 4, 5, 6, 7, 8, 9, 10. 10 take. So if I 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, 0, 1. Okay. 1, 0, 1. Okay. 0, 1. Then 0. Then 1. 0, 1. 3, 4, 6, 7. Yeah, it is giving correct answer. I'm praying for wrong answer, but it's always giving me correct answer. Is there be any optimal way to go here? Today means like you can jump. Like, how the question is saying why this is wrong? Getting like from this set. Task to spend the minimum possible point to move from first location to last one. I'm trying to see that where it could be wrong, but yeah, I'm not getting anywhere it could be wrong. So you can also see that it's not getting wrong anywhere. So I got कैसे करें मैं? So I can do this. What the thing is wrong, I'm not able to till now catch it out. If I get the debug, then only I can do na something. But here, like, what the thing could be? You can jump between adjacent location for free, as well as no more than once jump from any location with land I to any location I plus X spending X coins. No more than once. jump from any location with land I to any location with land I plus x. No more than once. Jump from any location with land I to any location with land I plus expanding x points. You can jump between, okay, as well as no more than once. Jump from any location with land I to any location with land I plus expanding x points. In between adjacent locations of 3 years. Let's see how we can do this right now. Everything I feels to be right now. Hope it would be unrated round. It would be so nice. But yeah, it would be a rated round only. So okay, so I don't think I'm right now. Okay, what could I do here? So finally, today contest was fully ruined. Not able to solve a single problem. Means attempted the first question that was wrong. Still, yeah, the logic I find out the how I can do, but maybe the answer is giving correct only. But I was not able to find where it is wrong. Fine. Maybe I wrongly interpreted the question. Now I'm going to ask one of my friend, like as you saw in standing position, that how he had did, and as well as we see that first question only 6,000 summation means the first question was tough. But yeah, it would be expected that I should solve this. But yeah, it's happened. Like last contest was good. Now it was bad, and yeah, it's a game of life. Graph would go up and down, negative rating, it's a part of life. Ultimately the rating would be there only where we stand for. Fine. So now on, and I also saw B, C, D. But yeah, means B, the time complexity would be the matter. In C, not able to think too much. Like yeah, that is the only case. Now that also case. Now like if you couldn't able to solve a question, so that confidence level is like break. But no problem. I know that this question was tough. Fine, not tough. Like some logic is hidden. It's not tough. I would ask then, or if possible, you can also comment out what the logic you clicked in first attempt. Uh, and yeah, now the another contest is on around means Tuesday. Tuesday Div 3 contest. So on that time, we will do our best. We will do good. And till that time, we will practice a lot. So and with consistency. So that's all for today. And goodbye. Thank you.